Okay, so I'm going to just tell you kind of a crazy story. We're going to think about how we can use probabilities to make fair decisions. So, let's say that you have a guy and another guy over here, okay? And these two guys, together they found, let's say a painting, okay? And it is a famous old painting you can just see, and this painting is worth a lot of money, okay? But the problem is that it's not worth um, a lot of money unless they sell it. They got to sell it, so they're going to sell the painting. um, and they can't cut it, they can't tear it in half. And it turns out that if they wait a little bit longer, this painting is going to be worth a lot more money. So, they try to figure out what's the fair way to share this painting. And they decide, one person, maybe this guy, he's going to give, some money to the other guy, right? Let's say it's $20,000, okay? He's going to give 20,000 to give up his share and just keep it. But the other guy says, no, I'll give you the 20,000. He's willing to do the same, okay? Rather than sell it today where it's less than an optimal time to sell it. So anyway, they come up with a way, and they say, here's the deal. They say, let's flip a coin 99 up to 99 times. We'll flip a coin, heads or tails, and the first one to get 50, wins. All right, so we'll call this guy heads and this guy tails. And the first one to get 50 wins gets to buy out the other guy for the 20 grand. Okay? So, implying that today's value is maybe 40,000, but if they can wait another year or two, maybe they get 200,000 or some crazy amount. So they're going to buy out the other person at today's price. Neither one really wants to do that. So then what happens is they go ahead and they start flipping coins, and they're coming up heads, tails, heads, tails. And they do this for a long time, and then a judge gets involved for some reason. I don't know. Let's say this guy's divorced. Now the wife, the ex-wife, she wants a piece of it, and the judge is going to force a sale. Okay? He's getting divorced, and so now they have to sell it. And they haven't finished flipping coins yet. I know this is a stupid story, but hang in there for a minute. So let's say that it's worked about like this. Let's say this guy has, at this time, he has 48 wins, right? And actually, let's say 40. Oh, let me just think. Let's say, hold on just a second. Let me get a. All right, yeah. Well, let's stick with 48 wins here. So he needs two, right? He needs to win two, right? And this guy, we're going to say this guy has 47 wins. So he only needs three. So now the question is, the judge is ordering a sale. There's no more time for these, little wagers, the little coin flips. The flips are just random. So now the question is, how do they split the 40 grand? They're going to have to sell it. So how do they split the 40 grand? Well, this guy, of course, says, hey, let's split it 50-50. He wants to split it 50-50. He says, hey, you didn't win. You're still at 48. I didn't win. I'm still at 47. We should just split it. We'll sell it for 40 grand. We each get 20. And this guy says, no way. He says, I got 48 wins and you got 47. So he says, I'm ahead, right? So I deserve greater than 50%. I want greater than 50%. And so this guy says, it's not my fault you're getting divorced. So you're the one that's, screwed us all up. I want to go 50-50. So as a compromise, this guy says, I'll tell you what, look. There have been 95 flips. And he says, I won 47 of the 95. And you won 48 of the 95. And he says, let's just split it that way. We'll take the 40 grand, divide it into 95 pieces. right? You get 48 of them, I get 47. Now, I'd ask you, is that a fair split? Is that the fairest way to split this thing? So just think about that for a second. Well, it looks fair, on the surface. I mean, this guy's won only one time more than the other guy. You're doing a pretty good job of splitting it up. But the reality is, are they pretty much this gives you an idea of how many wins they've had. But how close are they to actually winning? If they were playing this game, do we have a way to know how close they were from actually winning? Well, remember, the maximum number of flips that we can get, the max flips, would have been 99. And that's if one of them they both had 49 on the last flip, then the other one got 50. So I want us to think about how the remaining flips that exist, so they played 95 flips, so those remaining 4 flips, let's think about those remaining 4 flips. And then we'll use some probability. We're going to make a space in here, okay, that represents those 4 flips. So we have the situation where they could all come out tails. That's 4 tails, right? That could be one possible scenario. Then we have a situation where we get 3 tails and 1 head. Right? We could get a situation where we had 3 tails and 1 head. So what would that look like? Let's go head, then tail, 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 head, tail, 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 head, tail, and tail, 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 head. Right? We have a situation where we could go 2 tails, 2 heads. Okay? So 2 tails, 2 heads. Here we go. We got tail, tail, head, head, tail, head, tail, head, head, tail, tail, head, head, tail, head, tail, head, head, tail, tail. So let's see, I've got, what am I missing here? And I don't have tail, head, head, tail. Is that right? I have 3 of each. Yep. That is it, right? That's all the possible positions that could come up. 2 tails, 2 heads. The next one is 1 tail, 3 heads. So how could that happen? Well, we could go tail, head, head, head. Then we have head, tail, head, 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 tail, head, and head, 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 tail. And finally, we have where we could get 4 heads. 4 heads. So what would that look like? Well, we'd have head, 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 and head. So let's say that this is exactly what's going to happen. These are all the possible scenarios. Let's go over each of these scenarios and let's count them up. We're going to make a tails winning. Let's see, tails is this guy. So we'll put the tail winning subset, right? That's the tail winning subset here. And the flips that would be heads winning subsets. We'll put them over there. Okay? So obviously he already has 48. So anytime he gets 2 tails, as soon as he has 2 tails before the other guy gets 3 heads, he wins. So tails is going to win. So tail, tail, he's already got him. So this would be a win for tails, right? And now we've got heads, tails, tails. So he go to 48 and the other guy go 49, 50. So heads, tails, tails, tails. And in fact, all of these, this guy's getting 2 before he gets 3. So tails, heads, tails, 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 heads, tails, and tails, 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 heads. All right. That's one. That's through here. We've done through there now. Now we're going to do the next set. Tails, tails. Now remember, he has 48 wins. So by now he has 50 wins. So tails, tails, heads, heads is a win for this guy. And in fact, the other guy, he needs 3 heads. So he's not going to win on any of these. In all these cases, tails wins because tails gets to 50. 49, 50, 49, 50, 49, 50, 49, 50, 49, 50. The other only gets to 48, 49, 48, 49, 48, 49, 40. So, tails, tails, heads, heads. And then there are 5 more plus 5 more. Right? 1, 2, 3, 4, 5, 6. There's a total of 6. So 1 and 5 is 6. So these are the ones that end up with tails winning. Now, heads needed 3 heads to win. So now he's got 1, 2, 3, 4, and 5. You can see that there are 5 scenarios whereby heads wins. And 1, 2, 3, 4, 5, 6, and 5. There are 11 scenarios where tails wins. So we would use probability in this case. We would say, okay, you both agreed to this game, and the most likely at this point to win. The probability tells us that tails has an 11/16 chance of winning. These are all wins for tails. So if we were to draw his subset out, and actually we can just draw it like this. This is all tails wins, and this is heads wins. Alright? All of this on this side is tails wins, all that on that side is heads wins. So, really, the judge is very likely to take that 40 grand, force the sale, take the 40 grand, and give this guy 5/16 of the 40 grand. So we bring that down here, and we go, what is 5/16? So 5/16 times the 40,000, and he's only going to get $12,500. And this other guy, he's got the same calculation, only with instead of 5, because he has 11/16 chance of winning, the judge gives him $27,500. Wow. Now you wouldn't think that. They're so close. They're so close to each other, right? But the reality is, this guy's so much closer to winning. He's almost won the game, right? He's almost won. Of course he could lose. He has a 5/16 chance of winning, of losing. But he has an 11/16 chance of winning, and therefore he deserves more of the pot. That's how the judge might look at it. So I'm going to, this is an example of how when we look at, ways to divide a pot or a share, one of the things is we look at the probability of future events. So what's the probability of all the possible outcomes? So this one we just said, okay, there was a total of 16 possible outcomes, right? That's all the possible outcomes there were, and it was pretty easy for us to divide them up. In other scenarios, you might have to learn to use permutations or combinations to calculate the total possible outcomes, and then other series of permutations and combinations to calculate what percentage of them, represent, or to make the subgroups, or to make the subsets, right? So that we can calculate event A and event B and divide things according to the probability of outcomes. Okay, so this is dividing things fairly according to the probability of outcomes. And we are going to do some Khan Academy stuff now. Work on some of their problems and see exactly how they're done.